Hi, this is Discrete Structures. We're doing the homeworks for section 2.1. It's an informal introduction to elementary logic. Okay, so lots of word problems from that. Okay, great. So they start off with the following. So let's do number 1. P is it is raining. Okay. Q is the sun is shining. Okay. R is there are clouds in the sky. Okay, great. Okay, so now they give you English phrases and they say make them into symbols. Okay. If it's raining, it is raining and the sun is shining. So A is P and Q. B is if it is raining, then there are clouds in the sky. B is if it is raining, so P implies there are clouds in the sky. R. C. If it is not raining, then the sun is not shining and there are clouds in the sky. If it's not raining, so that's not P. If it is not raining, then the sun is not shining. The sun is not shining. That implies not Q. Okay. And there are clouds in the sky. And there are clouds in the sky. R. Okay. It could be that the not goes on both of them, but I'm going to leave it like that. Okay, D. The sun is shining if and only if it is not raining. Okay, D. The sun is shining. Q. If and only if it is not raining. Not P. Okay, so that's pretty easy. Oh, E. If there are no clouds in the sky, then the sun is shining. E. If there are no clouds in the sky, not R. Okay. If there are, then the sun is shining. That implies Q. Okay, so that's pretty good. 2E. Okay. Now, 2E, they give you the symbols and they want you to write the English. Okay. Translate the following into English sentences. Hold on. So let's erase this. Okay, so let's do this 2. Okay, 2E. Okay, what do they want? Not P or Q. Not P or Q and R. Okay, so let's do that. It is false that it is raining. Or the sun is shining. And there are clouds in the sky. Not the greatest English sentence ever written, but fine, that takes care of that. Why did I write ED? 1, 2, 3, ED. Why did I do that in that order? Let's see what D is. D. D is not P, double arrow, Q or R. Hold on. Not. Okay. So how about this? It is false that the rain is equivalent to the sun shining or the clouds in the sky. Okay, you really got to make it is false. That's the false. That the rain is equivalent. That's another way of saying this, equivalent or biconditionally, okay, to the sun shining or the clouds in the sky. So that takes care of that. Next, 6, B and C. Let's do this. 6, B and C. Okay, so again, this is not fun, whatever, but not hard. Okay, give the converse of the following. Let's just write it. 6B. So let's write this. If I am smart, then I am rich. If I am smart, then I am rich. Rich. Okay, so we'll write that as S arrow R, smart then rich. Okay, the converse is R arrow S, so that's if I am rich, then I am smart. Usually both of these statements are false. Okay, next. If x squared is equal to x, then x is equal to 0 or x is equal to 1. If x squared is equal to x, then x is equal to 0 or x is equal to 1. Okay, so let's just make sure we got it right. If x squared is equal to x, then x is equal to 0 or x is equal to 1. So how about this? We'll say square, then 0 or O. That's an O for 1. Okay? The converse is Z or 0 or 1, okay, implies S squared. Okay, so now let's write it out. If x equals 0 or x equals 1, then x squared equals x. That's the converse. Okay. By the way, both of them is true. Okay, great. Do the contrapositives of the propositions in exercise 6. Okay, so let's do the contrapositives. So let's just say with it. 6 was, if I'm smart, then I'm rich. The contrapositive is not rich implies not smart. If I am not rich, then I am not smart. By the way, it's just as untrue as that. One is not, these two are equal, but just that means that they have the same, they mean the same thing, but this is not true and this is not true. It's not always true. Okay, next. Okay, let's do the next one. We had what? We had square implies 0 or 1. Okay, the contrapositive is not 0 or 1 implies not square. Okay, so let's write that. Okay, so let's write this as x. Okay, sorry, it's false that x is equal to 0 or x is equal to 1 implies x squared x squared is not equal to x. Okay, we're going to fix this up. We're going to see another rule that has, this is the same thing as saying, look, if it's false that x is equal to 0 or x is equal to 1, that means one of these things is wrong. So you might as well write it like this. X is not equal to 0 and x is not equal to 1 implies x squared is not equal to x. This is true. And so is this. They're both true. Okay, so that's interesting. Okay. Okay, so let's do number 9. Okay, this part of the homework stresses the counterpositive. So let's do number 9. Hold on. N to the third is less than 3 to the n. N to the third is less than 3 to the n for all n, member of n. So here's a statement. Okay? It's not true. It's not true. It's not true, but we have to see why it's not true. Let's try a simple statement. Let's do n is equal to 2. So 2 to the third power, that's 8. Okay? And that's 3 to the 2, that's 9. 8 is less than 9. There, it's true. Hold on. So it's true for n is equal to 2. How about n is equal to 1? So then 1 to the third is 1, is less than 3 to the 1. That's true. True here, true here. So it's true for 2, it's true for 1. How about 0? 0 is less than 3 to the 0 is 1. True. So it's true for 2, it's true for 1, it's true for 0. But let's do it for 3. 3 to the third power. Question, is that less than 3 to the third power? And the answer is no, they're equal. False. So this statement is false. In fact, it's false for everything greater than, for 3 or greater also. So it's a counterexample. So this is a statement for all n. We found n is equal to 3 makes it false. Therefore, this statement is not true for all n, because at least for 3 it's false. It also happens to be false for 4, for 5, for 6, for 7, etc., etc. Great. Let's do another one. Number 11. Show, is it all 11? All 11. Okay, let's do it. 11. Show that x is equal to -1 is a counterexample to x plus 1 squared. X plus 1 squared is greater than or equal to x squared for all x member of the real numbers. Look at that. Okay, so we want to try x is equal to -1. So let's do this. -1 plus 1 squared is greater than or equal to -1 squared. Let's see. -1 plus 1 is 0. 0 squared is greater than or equal to -1. This is false. 0 is not greater than 1. So it's false. Boom, boom, false. Therefore, the whole statement is false. You find one counterexample, you find them all. Find another counterexample. Huh. So it says find another counterexample. Let's see. How about for 0? 0 plus 1 is 1. That will be true. How about -2? -2 plus 1 is -1. -1 squared is less than, okay, so let's do -2 plus 1 is greater than or equal to, this is squared, -2 squared. So this is -1 squared is greater than or equal to 4. Question, is 1 greater than or equal to 4? No, it's not. So that's another counterexample. That sounds good. Number 11, can a non-negative number serve as a counterexample? Okay, so now we're asking another question. If x is more than 0, anyways, the answer is, watch this, x squared plus 2x plus 1. Multiply this out. Question, is that greater than x squared? Let's see. Subtract x squared from this side, subtract x squared from this side. 2x plus 1 is greater than or equal to 0. When is this true? Minus 1 on both sides, you get 2x is greater than or equal to minus 1. X is greater than or equal to minus 1 over 2. So this is true whenever x is more than negative a half. So in particular, for all positive numbers, negative numbers, it's true. Okay, great. Okay, great. Next, we did 11. Now we do 12a. Just want to make sure I got it right. 12a. Find counterexamples to the following assertions. 12a. 2 to the n minus 1 is prime. 2 to the n minus 1 is prime. Let's see. Let's try 5. 2 to the 5 is 32. Minus 1 is 31. I think 31 is prime. How about 2 to the 4? 2 to the 4, 32. 16 is 15. 16 minus 1 is prime. No, this is false. So n is equal to 4 is a counterexample. Is a counterexample. Is that what they wanted? 12. Find a counterexample. Right. Let's just do, how about 8? 7. 7 is a prime. 4. 3 is a prime. 2 to the 0 minus 1. Okay, so that's equal to 0. 0 is not a prime, so I guess 0 is a prime. 0 is a counterexample. 0 is a counterexample. Okay, great. Number 14. I like number 14 because it goes back to the land of sets. So, A union B is equal to B union A. That is true. Okay, why? Which of the following assertions are true? For the true ones, give a reason. For the false ones, give a counterexample. A union B. So this is all things that have A or B's. This is all things that have B or A's. The word or is commutative, so that's not a problem. Okay, so this is true. Okay, next. A slash B. A slash B. Union B. Question is that equal to A? Okay. Let's see. A, B, A slash B. Union B. A take away B, union B, that's the whole thing. So that's A union B. No, it's not true. So let's give a counterexample. Let's see. If A equals 1 and 2, and B equals 2 and 3, let's go through it. So here's 1, here's 2, here's 3. So A slash B is equal to just the set 1. And A slash B union B is equal to 1, 2, 3. Okay, and B is only equal to 2, 3. So no, it's not. I'm sorry, A is equal to 1, 2. A is equal to 1, 2. This set is not equal to this set. It's not true. Okay, so this is not true. Great. A union B slash A. A union B slash A. A union B slash A. Question, is that equal to B? Let's just make a picture. A union B, that's everything. Take away A. So that's everything. Take away A. So I took away A. So this question, is that equal to B? No, it's not. Same counterexample will work. Let's do that. Okay? A is equal to 1, 2, 3. B is equal to 2 and 3. Okay? Now, A union B is equal to, A is equal to 1 and 2. A union B is equal to 1, 2, and 3. Okay? A union B slash A, take away A, is equal to 3. Exactly like we have that. Okay, question. B is equal to 2 comma 3. This set is not equal to that set. So that's a nice counterexample. It's false. Great. Next. Okay, the next one is simple. A intersect B intersect C is equal to A intersect B intersect C. Okay, and this is true because intersection is associative, that's what it says, but also the word and. These are those things that are in A and in B and in C is equal to those things in A, and in B and in C. The word and is associative too. Okay, last problem. Okay, each of the following sentences is expressed in an implication. Write it in the form if P then Q. Okay, this is, by the way, an English problem. Section 2.1 is a lot about English. Let's do that. Okay, so touch those cookies if you want a spanking. Okay, so another way of saying that is if you touch those cookies, then you'll get a spanking. No, that's not what it says. Touch those cookies if you want a spanking. Okay, so if, this is number 17, you want a spanking, then touch those cookies. Okay, that's A. Next, B. Touch those cookies and you'll be sorry. If you touch those cookies, then you will be sorry. Number C. You leave or I'll set the dog on you. Okay. If you do not leave, then I will set the dog on you. Okay, this one is worth doing this. This is basically leave, arrow, if you do not leave, so not leave, arrow, set the dog. So we'll set the dog on you. Okay, so if you do not leave, then I will set the dog on you. Another way of saying, we did this before, P arrow Q is the same thing as not P or Q. Okay, so let's do this. This is L or, I'm taking the negation of that, not, okay, or Q. So, two ways of saying it. If you do not leave, then I will set the dog on you. Let me read the original statement. You leave, or I will set the dog on you. Sorry, this should be a D. So this is two ways of saying the same thing. Okay, but they want it as an if-then statement. So that's what we did. I will if you will. Okay, so we'll do that like this. If you will, then I will. Okay, I will go unless you stop that. Let's just write this. I will go unless you stop that. Okay, keyword, what is the word unless? Okay, that means I will go unless you stop that. Okay. If you do not stop that, then I will not go. No, I will go. If you do not stop that, then I will go. Okay, I'm not sure about this one. Fine. Anyways, that's the homework for section 2.1. Have a wonderful day. Take care. This was easy.